repair my time machine. Welcome! Today we will examine the conduction of electricity through solutions. Some very electrifying experiments are waiting for us. We will check what solutions conduct electricity. We will use a battery as a source of electricity. We will construct an electrical circuit composed of a bulb, 2 graphite electrodes, and our solutions. Let's start. Let's see what happens when we dip electrodes in distilled water. Distilled water, water which thanks to distillation does not contain mineral salts or most other substances which contaminate it, as you can see, does not conduct electricity. It is used everywhere a very high purity of water is required. Car batteries or irons. Now instead of distilled water, I will use tap water. Water which flows out of our tap, as well as so-called mineral water, contains substances which dissolved in it, including salts, and unlike distilled water, it conducts electricity. Now it is time for alkaline solutions. Let's start with sodium hydroxide solution. A sodium hydroxide solution conducts electricity. Substances which exhibit such properties are called electrolytes. Let's move on to acids. Let's connect hydrochloric acid solution to our simple electricity circuit. Yes, hydrochloric acid is an acid that you have in your stomach. This solution needs to be an electrolyte. Can you see a shining bulb? Now let's try with sulfuric acid solution. You have just proved that aqueous solutions of acid conduct electricity. We can therefore include them in the group of electrolytes. Particles of acids undergo dissociation because of water. Acids are therefore, according to Mr. Arrhenius's theory, such substances which dissociate in water solutions into cations H+ and anions of acid radical. We will still have fun with salt solutions. We shall start with a sodium chloride solution. Bulb has lit again, so it is also an electrolyte solution. 0.9% sodium chloride solution is called physiological liquid, saline. It is used in medicine for irrigation and supplementing deficiency of electrolytes, and also as a liquid to wash eyes or wounds. Let's see if the same will happen with a solution of sulfate magnesium. Hydrated magnesium sulfate is commonly known as bitter salt or English salt. It was in fact mined in the United Kingdom, Epsom, and sold as a medicine with laxative properties. You might have noticed that after the graphite electrodes are immersed in salt solutions, we observe the illumination of the light bulbs in our test kit. Salts which dissolve in water conduct electricity as a result of the electrolytic dissociation they undergo. As you can see, only distilled water does not conduct electricity. The remaining solutions had the properties of electrolytes. In this experiment, we'll check which of the metals can be put into the bath. Do you think that a metal can be dangerous? Let's check it. What we'll need is lithium, sodium, potassium, rubidium, cesium, a big crystallizer with water, phenolphthalein and metal pliers. Watch out, because those metals are really active, and because of that, stored in a special way. The metals I've listed belong to the so-called active metals, which displace hydrogen from water in normal conditions. These are metals from the first group of the periodic table. Activity of the alkali increases with the growth of the atom's radius. Therefore, metals which find themselves at the bottom of the periodic table have the greatest reactivity. They react more rapidly, and as a result of these reactions, a big amount of energy is created. Such reactions are called exothermic. What's more, as a result of such rapid reactions, a hydroxide of a given metal is created. But remember that this is not the best method of producing hydroxides. Ho-ho! Let us check our theory. To the crystallizer, add a little bit of phenolphthalein, which will serve as an indicator. You remember it, don't you? Now, Master, you can choose a metal, which you should throw into the water. Remember to use pliers, and be careful. Why don't you try another method? That's not how it works, dear student. Try once again. That's not how it works, dear student. Try once again. You know what? I'll give you another chance. Those experiments are really explosive. Oxygen is indispensable for us people to carry out the breathing process, which provides us with the energy needed for life. It is used as one of the components of gas mixtures in oxygen tanks used by divers and mountaineers. Can we produce oxygen ourselves? Yes, of course. Let's try to carry out a chemical decomposition of potassium permanganate. In this experiment, we will use a stand with a test tube and bung, potassium permanganate, burner, glass vessel with a tube, a set of pipes and a torch. Pour several crystals of potassium permanganate into the test tube. Now we will build the set to run this experiment. To do that, join the glass vessel and the stand with the test tube. Don't you think you should do it a different way? Add pipes to the set. Now the time has come to heat the potassium permanganate. To do that, use the gas burner. You should heat the test tube in the flames of the burner, causing the potassium permanganate to decompose. As you can see, the gas that is emitted is gathered in the test tube filled with water, which is placed in the vessel. If you've already carried out the experiment, do all the gases sustain burning, you probably already know in what way we will identify the gas product of the reaction. To do that, place the glowing torch in the test tube with gas. But do it quickly so that the gas will not escape. The torch is really burning. This proves that the product of thermal decomposition of potassium permanganate is oxygen. It is a colourless and odourless gas that dissolves poorly in water, which is why we could have gathered it in this experiment from above the water. As you can see, it sustains burning. Welcome! Did you know that chemistry is full of colours? Many salts colour the flames of a burner. During this series of experiments, you can take a closer look at colourful chemistry. In this experiment, we will need a burner and salts in alcoholic solution, sodium nitrate, barium nitrate, lithium nitrate, copper 2 chloride, potassium nitrate, and rubidium nitrate. There's no time to waste. Grab the first salt and check what flame colours it gives. Yes, we've already made green flames, but we didn't use barium salt for that. What is interesting is that barium compounds absorb X-ray and gamma radiation very well. and that is why they're used as a radiation cover component. Potassium in the metallic form is very soft and can be sliced with a knife just like cheese. Additionally, it is a very reactive metal, something you will find out about in our next experiments. Ho ho ho! You've probably already seen such colour of flames, haven't you? If not, then take a look at the colour of the flames under boiling potatoes, when the water boils over. We salt potatoes, and salt is sodium chloride. It is sodium that gives the yellow colour of the flames. Lithium salts are used in medicine to treat mental disorders. However, the exact mechanism of lithium ion's activity is unknown. Perhaps you'll be able to solve this riddle. You will not find rubidium in a metallic form in a shop. It is very expensive and reactive. But don't you worry, we will use it soon. Ho ho ho! Copper salts often give different shades of blue, and this is why, among others, snails have blue blood and not red as we do. But this is a story for our biology lessons. Congratulations! Chemistry also has much more colours. If you want to check it, then go to the next experiments.